We assume more protection makes AI safer, right? This paper reveals why that's not always true. Let's get into it. Let's start with a featured paper. Same dangerous objective, opposite advice. Direct exposure versus multi-agent mediation. By Linjun Li. This work uncovers a critical and counterintuitive vulnerability in LLM safety, demonstrating that indirect interaction can paradoxically make models more dangerous, which has significant implications for multi-agent system design. Here's a full breakdown.
First, let's look at the direct path at the top of the diagram. Here, the raw private objective and the public transcript are fed directly into a single model call, which generates the user-facing reply. In contrast, our mediated path introduces a multi-agent framework to process the same inputs. This system is composed of three distinct components: the ID, the sensor, and the superego, which work together to handle the objective. Feeding into this, the ID and sensor agents work together to transform the objective. The ID produces an initial message, which the sensor then alters into the modified intention I. Next, the superego agent receives this carefully modified intention. It combines this with the public transcript X to generate the final reply, all while being shielded from the original raw objective.
Up next, our second paper out of 3, RL Macro, a cybernetic closed-loop intelligence framework for multimodal adaptive robotic craniotomy by Xiao Zhang and Xiang Li from Dalian University of Technology. This paper presents a sophisticated, closed-loop robotic system for a complex medical procedure, demonstrating significant advancements in autonomous surgical capabilities. Let's break down its key contributions.
Our system begins with the multimodal latent temperature state observer at the top of the diagram. It takes in real-time force and sound sensor data from the procedure and processes it through a CNN-LSTM network to estimate the otherwise unobservable tissue temperature. This temperature belief state then feeds into our RL-based decision-making agent. We use an implicit Q-learning framework, represented by the Q functions and value function networks, to learn an adaptive policy from an offline dataset of surgical data. Next, within the agent, an actor network, labeled PyPhi-AS, processes the current state to make a decision. This component intelligently coordinates the action outputs, determining the optimal robot velocity, tool spindle speed, and cutting depth for the next step. Finally, the agent's high-level decision is passed to the dynamic trajectory planning module to be executed. The commanded feed velocity enters a velocity profile generator, which works with the velocity servo loop to ensure the KUKA robot arm follows the planned path smoothly and accurately. The RL method substantially outperforms the mean action baseline in terms of cumulative reward and safety, consistently staying below critical temperature and force thresholds. Quantitatively, RL achieves a positive return of 116.05, significantly higher than the baseline's negative return of minus 93.21, while also maintaining lower maximum temperatures and forces.
Up next, our third paper out of 3, Do Pathology Vision Language Models Truly See Pathology? By Chengyang Zhang and Qinshuan Deng from Sichuan University. This paper delivers a crucial and timely critique of current evaluation methodologies for pathology VLMs, exposing fundamental flaws that challenge the perceived progress in the field and demand immediate attention. Let's break down its key contributions.
To rigorously evaluate pathology vision language models, we introduce PathBind, a new comprehensive benchmark. The final composition, shown at the bottom, brings together 2,600 diverse samples to assess these models. Feeding into this, the benchmark features 3 distinct components, each designed to test different capabilities. In the final samples column, you can see these are PathBind VQA, PathBind PDA, and PathBind rounding. Next, to create these high-quality samples, we use a robust curation process involving both automated filtering and manual review. This multi-stage process, including expert review by pathologists, refines the data for clinical realism and accuracy. Vision language models, VLMs, consistently outperform both the random choice baseline and their text-only counterparts across all pathology benchmarks. The best closed-source VLM, Gemini 3 Pro, achieves an average score of 76.0, while top open-source models like PathGenLAVA and Qwen3VL 32B reach averages in the mid-50s.
Those were the top papers. Now, let's zoom out. ArXiv received 620 new computer science papers across 53 subfields today. Here are the trending areas shaping the field. Zooming out, the day's research clustered into 5 big themes: data efficiency and semantic understanding, graph-based system security and learning, probing and improving LLM behavior, workload optimization and code generation, robust multimodal model adaptation. The full paper list is in the pinned comment below. That's all for today's ArXiv Computer Science Daily. If you found this helpful, please leave a comment, and subscribe for daily paper summaries. See you tomorrow. Thank you to ArXiv for use of its open access interoperability.